Here is an easy way to deal with integral arctan of x, or as known, tan inverse of x. The best way to start, a quick way, is just use the first change of variable or integration by substitution, in which we name, say, u equal to arctan of x, which means x is just tangent of u. So with this change of variable, we can just rewrite this integral in the form of integral u and then d tangent of x, tangent of u. Okay, next step, let's use the integration by part, in which we're going to write integral u dv equal to uv minus integral v du. Okay, so here is u and here is our v. So it will be as easy as just writing this in the form of u tangent u and then minus integral v du, so tangent u du. Okay, so we have to deal with this integral, and then after that we have to substitute for u here, which we can do it by now as well. So tangent of u, of course, is x, and u itself is arctan of x. So we can write this in the form of x arctan of x, or tangent inverse of x. Okay, and for this one, we use this trick that tangent is just simply, by definition, sine over cosine. And of course, one thing we know is d cosine, or let me write it here. It's better to just write it here. So we know by definition of derivative of cosine, d cosine u is negative sine u du, which is what we have here actually, negative sine u du. So I can rewrite this integral to keep the x tangent inverse of x as it is, and then for this one, let me write it in the form of plus minus sine u du becomes d cosine, and then we have cosine u. So, or if you wanted to write in a cleaner fashion, we can write it this way. Okay, 1 over cosine u, d cosine u. Okay, so this one is easy because we have d cosine u and 1 over cosine u. You can think of cosine u as w, so it becomes 1 over w dw, which is simply ln w plus c. So ultimately what we are getting is, again, x arctan of x is there. And then for this one, we have ln of cosine u. And then, of course, a constant c. Okay, as one last step, we have to substitute the remaining u with what we have here. U is arctan of x. So what I'm going to do is I'm going to use this the well-known trigonometric property that tangent of, let's say, u squared is cosine squared, and then sine squared is 1 minus cosine squared over cosine squared, and of course this is 1 over cosine squared plus minus 1. So as a result, I can write simply this, that cosine squared of u is 1 over 1 plus tangent squared of u. The nice thing about this is we have tangent of u equal to x. So what I can say here, maybe I just make it a little bit better written here. So what we have is 1 plus tangent squared u, which is effectively from what we have here, 1 over 1 plus x squared. So over here, what I have is x tangent inverse x, and then if I write, let's say, minus 1 over 2 ln, it becomes cosine, and we can get rid of the absolute value, of course. It becomes cosine squared, or uh, let's put it this way. Let's put it this way. Because I used the trick that I applied -1/2 here, then effectively it becomes 1 over cosine squared of u, which is 1 plus x squared. So as a result, the final answer here is equal to x tan inverse of x minus 1/2 ln 1 plus x squared plus c. This is the answer. C is the constant. This is the answer that we were looking for. I hope that this is helpful.